What about this Nibiru, the brown dwarf? What is this?
That is, what should I say, an observation from ancient civilizations, the Sumerians, that there could be other planets like that. Astronomers, scientists have seen no evidence. We have discovered new dwarf planets, Eris and others. We're looking for planets around other stars and finding them, but there is no risk of a renegade planet hitting our planet in 2012.
Now, there are literally millions of asteroids and comets zooming through our solar system, and a number of them apparently pose a potential threat to Earth. Well, it's NASA's job to monitor these flying rocks, but it lacks the money to do it properly. For more on funding the Meteor Hunt, let's join RT's Dina Gazowski in our Washington studio. Dina, tell us all about it.
Hi there, Carrie. Well, imagine this scenario. NASA, the one institution responsible for spotting asteroids that could pose a threat to planet Earth, apparently doesn't have enough money to do this. This is according to a federal report. But how could the U.S. government allow this to happen? Well, apparently the United States Congress assigned NASA with this mission several years ago, but never really gave it the amount of money it needs to update its telescope systems. This is crucial for completing this mission. So what will happen now? Armageddon? After all, this is an issue that doesn't just affect the United States and Russia, but really planet Earth itself. Well, here to discuss these scary, scary prospects, Baron Soka from the Space Frontier Foundation. Thank you so much for being here. So according to this report, NASA is able to only complete 1/3 of this project because the telescope systems aren't updated. So what does this mean for this mission and for all of mankind then?
Well, NASA needs $1 billion more to keep tracking these asteroids over the next 12 to 15 years. And it's important. It's both a huge threat, as you say. It's a very small likelihood that any particular asteroid will hit us, but if it does, it could be the end of the species. But it's also a great opportunity. These asteroids are worth something like $100 billion per person in total if we were to mine them. So this is a great opportunity for the species as well as a threat.
So why is the United States Congress not giving this agency the amount of money it needs? Does it have anything to do with the economic crisis, where they're kind of cutting corners everywhere that they can?
Well, they never funded it to begin with, and the problem is that policymakers just discount things that are unlikely to happen, but have a very, very high cost. It's very hard to get them to deal with that sort of threat.
Now, you mentioned threats, and NASA says that there are about 20,000 asteroids and comets in our solar system that are potential threats. So should we all be in panic mode here? I mean, what can people do to make the Congress give them money?
Well, recently a big asteroid hit Jupiter. We didn't see it coming. It created a big spot on Jupiter that was something like 1/5 the size of Earth. So it is a real threat. It did kill the dinosaurs. We should worry about it, but it's also something that's not likely to happen tomorrow. So I think what everybody should do is Americans should write letters to their congressmen to ask the U.S. government to fund NASA to do this. And we should encourage other governments to invest in tracking. Germany and Canada are building satellites to do this, and
yeah,
that's a good thing.
Talk about other governments, because this is really a global problem. You know, it's not just country-specific.
Right. Well, the U.S. government's taken the lead here. NASA is the only organization on the planet that has the mission of tracking these asteroids. And it's something that governments really should do. It's about the defense of not just a country, but of the planet and of the human species. So it's something we should all invest in.
Now, you spoke about a silver lining here, which seems kind of strange considering that everyone's kind of panicking and we're hearing about all these threats. So what is this silver lining?
The silver lining is that, that metal prices are what restrain our standard of living on Earth. And the reality is that our solar system is full of metals. Platinum, for example, is the main ingredient in fuel cells, and it's what makes them so expensive. But if you could bring down the price of doing that by mining all the platinum that's in these asteroids, we could have far greater wealth on this planet and environmentally friendly technologies like fuel cells and hydrogen instead of internal combustion engines.
Well, that's interesting. Maybe perhaps a silver lining in all of this. For now, back to you in Moscow, Carrie.
Yep, scary stuff there. Dina Kozlowski, thanks very much indeed.
The number of people worldwide who are working actively on this problem is enough to staff one shift at a McDonald's. And that's about accurate.
If we discovered tomorrow that a huge asteroid was hurtling toward Earth, the world's attention would turn toward NASA astronauts Ed Lu and Stan Love, who've developed what experts say is perhaps the best plan to save the planet.
But here's something that we have a chance to not just control, but prevent. The asteroid will miss the planet, no damage done whatsoever, if we can do this properly.
Regardless of what we see at the movies, the one thing we don't want to do is blow the thing up. All that would do is transform one big asteroid into thousands of smaller ones that could cause even more damage. Instead, these NASA astronauts say that with enough advance warning and a big enough ship, they could fly millions of miles into space, rendezvous with the asteroid, and use the ship's gravity to nudge it slightly off its deadly course.
The tiny gravitational pull between the asteroid and the spacecraft will be enough to pull an asteroid onto a new orbit so that 10 years later the asteroid misses the Earth rather than hitting it.
That's the theory anyway, but it's still just a theory. There is no spacecraft yet, not even a blueprint.
I like what they always show in Hollywood. As the asteroid comes, people hear it and they look up and they see this flaming ball moving. These objects are moving 10, 15 miles per second. That is hypersonic. You're not going to hear it, you're not going to see it.
It takes it a few seconds from when it first hits the top of the Earth's atmosphere to when it actually touches down. During those few seconds, it glows, not red hot, not yellow hot, white hot, getting up into violet hot. And that is so hot that if you were anywhere on Earth in the big circle of maybe 1,000 miles diameter, where you could actually see this thing coming down, the heat and light coming off of it would just burn you to death immediately.
What about this other idea of solar maximums? This idea that possibly we could have a peak of solar flare activity, at least in a couple of years, and that could, even if it doesn't lead to the end of the world, could cause power outages, could fry our grids, and we could be in the dark.
Well, of course, the solar max is coming. We can't stop that cycle, and we expect it will peak in 2012, 2013 or so. We're watching it. We have a new satellite that will get the most incredible data on it, the Solar Dynamics Observatory, going up in about a year. So there will be effects. We've had...
Oh, what are those effects going to be now? Those solar max, you said that is something to keep an eye on in 2012, just so happens possibly. So what are the effects going to be of those flares?
Well, depending on how big they are, we can have outages of cell phone. We can have disruption of GPS service. We could have some of the satellites that give us our information on weather could go into a safe hold where they're waiting and watching until we can bring them out of sleep. Lots of little things can happen like that, but nothing unusual.
That sounds unusual. That sounds like scary stuff there, Doc.
Well, it is, but you know, we've designed our systems. We're a lot of great engineers at NASA to live through these things, and we've done it before.
All right, movie comes out this weekend. You going to go see it?
Oh, absolutely. Hollywood's fun, and so is science.
Professor and author of the book Physics of the Impossible is back with us. Professor, how are you? And good morning to you.
Glad to be on the show.
Thanks. Twice in 1 week, man. It's bonus hour. What is this solar shield?
Well, every 11 years, the sun has a temper tantrum. It releases a shock wave, a tsunami of radiation that could wipe out communication, weather satellites, GPS, spy satellites, you name it, it's up there in outer space.
So you're saying that my BlackBerry won't work?
The internet, Fox, television, cable, satellite TV, all of it could get wiped out around 2012. That's when we have the peak of the sunspot cycle. That's when the sun's magnetic field flips. North Pole and South Pole flip, releasing a shock wave of radiation, which will then hit the Earth minutes later, potentially wiping out a good chunk of our satellite communications. We're watching it very carefully now.
Well, Doc, this happens how often, you say?
Every 11 years.
Well, why an 11-year cycle?
It takes 11 years for the magnetic field of the sun to build up enough intensity to begin the flip process, because it slowly revolves in a circle. It's like winding up the windings of a clock. If you wind up the mainspring of a clock too much, it boing, comes out of control. Same thing with the sun's magnetic field. It literally flips every 11 years, releasing a shock wave of radiation, and that means we have to start to think about reinforcing our satellites, building redundant systems, because it means that GPS, the power grid, weather satellites, communication satellites, satellite television, all of that could get disrupted, peaking around 2012.
So your point is we can't do anything about it in space, but we can do something back here on Earth.
That's right.
But backup systems, are companies really doing that?
Well, they're going to have to do it because, see, we scientists made a mistake. We thought that the next cycle was going to be quiet. Well, some of our data was off by a factor of 20, and that's why we're issuing this alert now. We made a mistake. The next cycle, peaking around 2012, will be much more serious than we previously thought. Now, in the past, we dodged the bullet because we didn't have that many satellites up there 11, 22 years ago. back in 1990, we didn't have that many space satellites.
So while we all went about our lives yesterday, we came very close to a catastrophic event here on planet Earth, and we didn't know about it. It turns out we just missed getting hit by an asteroid, a piece of solid rock, roughly the size of a 10-story building. Now, I say just missed because it came within 45,000 miles of us. That's a lot closer than the moon is, and scientists say way too close for something that big. Had it struck, again, the people who tell us about these things, say the impact could have had the force of 1,000 Hiroshima-strength atomic bombs over a huge area of the Earth.